Here we're going to continue our work on the area between curves. We're just going to tackle examples that are a little bit trickier. So we'll remind ourselves of the formula. So it's just the integral of the top function minus the bottom function, and then the bounds. The bounds are where the two curves intersect. Okay? And looking at that and then looking at our first example here, it should be clear why these are a little bit more complicated. So notice this, in this example, the two functions intersect in the middle of the boundary we're interested in. Okay? So the top function and the bottom function switch. Okay, so this is really, you're probably good at using your calculator for these integrals now, but this is really an exercise in figuring out how to write these down, which is definitely worth some practice. So the way I would write this, so we have our two functions, right? Obviously my parabola is on top to start, so the way I'd write this would be from the integral from 0 to, oh, and I have no idea where that point is. So the integral, we're going to have to find that first intersection. Okay, so I'll show you how to do that graphically. Okay, so I've typed in my two functions into my grapher. I'm going to adjust the window. I'm probably just going to leave it mostly alone. But I'm going to adjust the x max to 1.5 because it gives us that value as the upper bound for x. I'm going to adjust the x min to 0 because that gives us that as the lower bound, or it shows us that in the graph, I guess. And I'm going to graph them. Oops, I messed up here. Ah, yes, negative. I always do that on the internet calculator. I'm going to graph them, and I should get a picture that looks pretty much like my picture here, right? Now, I need to figure out where these graphs cross because it's not given to me. So I'm going to do second, calc. I want intersect now, so that's choice number 5. First curve, it doesn't matter which is your first curve. It can be the parabola, that's fine. Second curve is going to be your line. If you've only put 2 in, right, this is easy. And then it's going to be like guess, and then it's going to solve that for you. And it's going to give me that intersection as 0.687. 0.5687, I meant to say. So that's going to be my upper bound, 0.56, and I'll say 0.569. Okay, so that's that intersection here. And obviously this has a y value too, but we don't need to know what it is. And then we want to do top curve minus bottom curve. Well, my top curve is the parabola in this case, 4x squared plus 9 minus 3x plus 6 dx. And then my second integral, well, it's going to be the integral from now that intersection point again, 0.569. So that's, again, this spot. Now we're going to 1.5. And then now my curves have also flipped. So my top curve is now the linear curve, so 3x plus 6 minus negative 4x squared plus 9 dx. Okay, so this is my area, or a representation of my area. I'm going to go back to my calculator, and I'm going to use it to solve this. And the way that I'm going to do this is by very cleverly saving myself from having to retype this. So I'm going to get out of my grapher. I'm going to do math, and then I want an integral, obviously, so fn int 0 to my upper bound, which is 0.569. And then in here, I'm going to get clever. So remember, I have my parabola on y1 and my line on y2, right? So what I will do is I will do alpha f4, and this gives me my list, right? So y1 was my parabola minus alpha f4, y2 was my line, integrate with respect to x, and then I can do that same thing all over again. So fn int, and then 0.569 to 1.5. And then the upper and lower curves have switched, right? So I'm going to do them in the opposite order this time. So y2 first, minus y1, and then dx. And now I'm going to hit enter. And this is the area between the two curves. So by storing those, what was it, 5.326? By storing those in y1 and y2, you have to put them in there anyway to find the intersection. But by storing those and typing them in that way, I've saved myself a whole lot of work and a whole lot of opportunities to make errors typing this in. Okay, so the complications here are that you must find the intersection, and the top and bottom curves tend to switch. Okay, so figuring these two things out is the work that you're doing. Let the calculator do the rest of the work for you. And using those y variables to save your functions is going to save you a lot of headache here.